Yeah, hi everybody. As said, I'm Matt Johnson. I'm a developer advocate for Prisma Cloud by Palo Alto. I'm here today to talk to you about supply chain best practices. This talk kind of has two titles. Supply chain best practices is nice and easy and catchy. But the real talk of the title is easy things you can do to improve your cloud security posture. So the idea with this session is, after you've watched it, there are things you should be able to do and go, maybe in your next lunch hour, that will give you a lot more insight into your kind of cloud security standing than maybe you have right now. So hope you find it interesting. Looking forward to some Q&A afterwards. You can always reach me at Metahertz, and I'll put my contact details on the slides if you have any follow-up questions. Yeah, this is the real title, easy things you can do to improve your cloud security posture. So let's get into it. I'm Matt Johnson, as I said, coming from Palo Alto. There's my Twitter if you want to follow up afterwards. I've been playing with securing containers and containers in general since before they were called containers. Hands up if anyone remembers Solaris branded zones. Just me. Okay. Hobbyist pentester, training to get my private pilot's license, and general tinker and breaker of things. So let's start with a bit of context. Like, why supply chain? WTF? And when we think of, I'm sure all of you will have seen some kind of diagram like this, right? The idea that we have this entire stack of things we need to build out our infrastructure. We have, whatever the infrastructure as code we're building to create the VMs, the containers. We have the container builds themselves. We have all these open source libraries as dependencies of our applications because, you want to write a simple hello world application. And so you go like npm install colors, and npm installs a billion packages from the internet to make that simple application work. And generally, when we think of kind of software supply chain, we think of the security risks, the potential CVEs in those open source packages within our applications, right? We think about, what node npm is downloading for us, what pip install is downloading for us, things like that. But there's a second there's a second area of supply chain that is regularly overlooked. We all know that we need to check our dependencies for CVEs, especially after Log4j and things like that. That's been all over the news. But when we think about our infrastructure as code, when we think about our Terraform and our Kubernetes manifests, we also have that same issue. If we take a look at that first line down there, what we actually end up with is something like this. So we actually end up with a second set of open source dependencies, because when we're writing Terraform, realistically, if we want an EC2 instance in a new Amazon VPC, we're not going to go and write all that Terraform ourselves. We're going to use an existing Terraform module maintained by someone else that we've got from the Terraform registry, for example. Or if we're writing Kubernetes, or we need to stand up some services on Kubernetes, we're probably going to go and see if there's a Helm chart or a customized set of manifests that have already been written by the community from somewhere like artifacthub.io. And so we actually have almost like I've called it TCA. So like, a tooling composition analysis as well as a kind of software composition analysis, because we also have dependencies there. What I was basically saying is the same is true of our infrastructure code. We have, all of these third-party dependencies, and we don't know the security of those, whether they're written, securely or they're written for ease of use. So we have the same issues with software dependencies and security down at our infrastructure as code level. So let's tackle that first. Next slide, please. So we have, spoiler alert, an open source tool called Checkov. And Checkov has had over, by the last time I checked, like 38 million downloads. And the whole point that Checkov was written for, the reason it exists, is it's trying to create developer-friendly infrastructure as code security, because we're all familiar with knowing we need to check for CVEs in software. People aren't as familiar with realizing that actually, if you look at a lot of the, OWASP 2021, 22, 23 top 10, you look at the recent LastPass exploits, which involved, stealing of people's encrypted vaults. All of those weren't CVE related. All of those were misconfigurations which occurred at the infrastructure level, or the infrastructure as code level, which were just as dangerous as a CVE, as a vulnerability in your application code. So Checkov is designed at its core to scan pretty much every type of infrastructure as code language you can imagine. So Terraform, Kubernetes, Kustomize, ON templates for Azure, CloudFormation. And it's designed to find issues that aren't security best practices. So you can see here, we can run Checkov, we can tell it to recursively scan a directory. It will go and pick up by default any infrastructure as code type it finds, but otherwise you can say, hey, I just want you to find Terraform as here. And you'll see from this example, we're finding some issues. And we're going to highlight the exact bit of code in your Terraform, what needs to change. And also, as you can see there, there's a guideline link, which allows developers that maybe aren't, security practitioners, to go and actually get a bit more context about why Checkov is giving this issue, and a bit more reading as to why this is an issue, and often what can be done to change it. And this is great. This is where Checkov started. But, in DevOps and DevSecOps, we're all about, not annoying your developers and, making their lives easy. So another command that every dev has to run every time they make a change to their infrastructure, probably not the best. So let's try and make this a bit more friendly. Next slide, please. What we can now do is, take Checkov and instead put it into our CI/CD. Checkov was designed to run in CI/CD. It's got a load of integrations for pretty much every CI/CD tool you can imagine. Here we see an example of, at the top, we see an example of Terraform Cloud automatically running Checkov security scans and allowing Terraform Cloud to either block the build or warn before creating real Terraform objects in the wild. And at the bottom, we see integration directly with GitHub Actions, where we're actually modifying the open pull request we scanned and making suggestions based on what we can do, if we know how, to kind of fix those Terraforms, Terraform modules and Terraform code in terms of making it more secure. Next slide, please. But again, we can go further, because by the time you are running CI, as a developer, you probably think you're done, right? You've already made your changes. You've already named a commit. You've already pushed that commit. That thing is in a repo somewhere. Wouldn't it be better if before we got to any of that and then waited for CI to fail or not fail, we had heads up on this information directly where we live in VS Code and IntelliJ? And I say those two because those are the two we have a Checkov plugin for. So what you see here on screen is exactly that. When you're writing Terraform, you get that wonderful little squiggle underneath an individual resource, and we will tell you the things that Checkov is going to find automatically there in your IDE, which makes it super developer friendly. And also allows developers to kind of have a better relationship with security teams, because, at that point, there's no point submitting that to CI because it will fail. So it's better doing that than wasting your time waiting on a CI build and things like that. Next slide, please. And as I said, that's just another view of VS Code showing all the issues directly in there. Next slide, please. And so that's great, but we're here to talk about supply chain. And as I said, templates are often forgotten. If there's one takeaway from this talk, try Checkov, understand things that maybe you weren't thinking of in terms of your security posture. It's open source, and it might be amazing what you find. And once you know your unknowns, you have a better choice to prioritize them. I'll come on to that a bit later. But in terms of the entire, build lifecycle from kind of code to cloud, we've still got a lot to tackle, as we see from this image. We basically just talked there about insecure templates, creating insecure configuration in the cloud. So let's see what else we can do. Next slide. Now, as I've touched on, that Terraform doesn't magically create infrastructure for us. And, not everyone is just born with a Kubernetes cluster with their name on in a cloud provider somewhere. We actually have to turn that infrastructure as code. We have to turn those application code into Docker images, into real infrastructure. And this is done through, squiggles and lines like in the diagram. This is done through CI. Pick your favorite CI. We're not biased. And that's, we need a CI pipeline. Okay, next slide. And with CI pipelines comes even more attack vectors that you need to think about. I would highly recommend my colleague Steve's talk on pawning GitHub Actions. The link is down below in this slide, and he's actually up a little bit later on today giving a keynote on high-level supply chain goodness. So stay around for that. Next slide, please. So what can attackers do with CI? Well, as you will see from Steve's talk, and I'm kind of paraphrasing very quickly, but imagine that you thought you had secure Terraform, but your CI pipeline using, a simple CI pipeline that helps developers by automatically tagging issues, for example, and using user input. Just as dangerous as using user input in your application. You can use variables in CI pipelines to basically run, malicious code within the pipeline, and then subvert the pipeline to add or change the code base, add or change the infrastructure, disable security features, you name it. Get a reverse shell and steal all of the credentials from your Git runners that are running your CI pipeline. So yeah, really dangerous stuff. So we need to watch out for that as well. Next slide. Couple more resources on this before I kind of say how we try and tackle these issues. If you want to play the attacker and understand these in more depth, our good friends and teammates that came into Palo through the Cider acquisition recently have this awesome resource called CI/CD Goat, which will actually let you spin up a set of vulnerable CI pipelines and kind of hack them just to kind of see the danger that they cause. Next slide, please. So securing your environment isn't not infrastructure as code alone. We need to make sure we are not deploying insecure packages, CVEs. So this doesn't eradicate all the regular application security scanning. As I've just said, we need to protect our CI pipelines from abuse and takeover. There's also some issues with the base Git repo default configurations in a lot of places like GitHub and GitLab, in that maybe it doesn't have multiple reviewers turned on in order to merge a commit, which makes kind of repo takeover or repo poisoning actually a lot easier than people would think. So we need to make sure our security settings on our Git repo are correctly set. We need to make sure that the containers we're using, especially if we're kind of using other people's containers, from Ubuntu, from Python, for those building Docker files, we need to make sure that they don't have any CVEs lurking in their libraries. And also just the basics, which are still a massive issue. We need to make sure we're not storing secrets insecurely. Yes, that means we're probably all going to have to install Vault at some point, but it's not the worst thing in the world. Next slide, please. So luckily, Checkov has kind of evolved from just infrastructure as code scanning, and it has a few more tricks up its sleeve to try and fix or at least highlight some of these issues. Next slide, please. And yes, for those wondering, my arm is getting quite tired. I should have found a little stand, but time was of the essence. So as you'll see, if you do Checkov --help, and you can install Checkov via pip install Checkov, you can Docker pull bridgecrew.io/Checkov. Google Checkov or go to checkov.io and you'll find all the installation options. But you'll see we have a load of different frameworks. In fact, the list is getting longer and longer pretty much every time I have to edit this slide. You'll see there we have GitHub configuration. We have GitHub Actions. GitLab configuration. And these cover what I was just talking about. We can, taking an API key for your GitHub account, we can go and check your GitHub configuration, making sure that you have turned on multiple approvers for a PR, making sure people can't do same person PR approval to push things through without community consensus. All these good defaults that should be defaults and aren't. Although credit to GitHub, they are getting better at turning some of these on by default. We have, as I said, frameworks for Kubernetes, customize Helm. We have secret scanning, which has a really cool new feature where it actually, as of last week, will go and prioritize that feature for you. I'll come to that in a minute. Next slide, please. So here we can see an example of the GitHub Actions part of Checkov. Not only now checking just your Terraform, but also going, hey, you have an insecure GitHub action which could allow attackers to compromise your CI/CD, could allow them to run their own commands in your CI/CD, or not. You see both of these are passing, which is good, but if you get failures on this stuff, it's, again, you have guidelines to read and understand those issues, but it's definitely something you should take notice of. Next slide, please. So with those features in Checkov, that starts to get us, a little more green on this diagram. And, green ticks are a good thing in security from what I've heard. So let's see what else we can achieve. Next slide, please. The next up is CVE scanning. As I said, you can't ignore it. So anytime Checkov, obviously we're dealing with infrastructure as code. So the chances, the references to application code we're going to find in our infrastructure are going to be Docker files, or they're going to be links to Docker images in our Kubernetes manifests or our EKS cluster configuration. Using an API key, and I'll get onto, some of the nuances and build versus buy with some of the features in Checkov. Obviously, there's a lot of resources behind the scenes to go and unpack and extract and CVE scan containers. But using an API key, Checkov can automatically find, detect, and scan and give you all of those CVEs alongside your infrastructure security recommendations. And then finally, at the bottom of this screenshot, we see it will also do secret scanning. And the new feature about secret scanning, which is really cool, well, two new features. Number one, it can go back through your entire Git history to make sure that even if there's no secrets in the current files, there's also no references to secrets left in previous commits that maybe have been squashed, or maybe you don't think that data's there, but attackers are already looking kind of deep in the ref log of Git to find those things. So we also do the same just to make sure there's no lurking secrets. And then in terms of prioritization, we can also test those secrets for liveness. So, what happens if you have 1,000 secrets show up across your code bases? Well, you prioritize the ones that are actually real tokens that really give access. So we can also provide that by automatically testing those as well. Next slide, please. So that gives us secret scanning. That gives us the ability to scan malicious images, as I said, with caveats. Need an API key for that, but I'll come on to that. We've scanned our version control, our GitHub configuration. We've scanned for issues with CI/CD pipelines. For a single tool that is really easy to either deploy in your CI/CD pipeline or run standalone, why wouldn't you give this a try? Even if you're scared of what you will find, my advice would be, all of these things are a risk. They're just as much of a risk as, CVEs in your app code. So, definitely try and understand if you've got any hidden gaps in your security posture with tools like Checkov. Next slide, please. Okay. And then you're just going to have to take this from me. This is about as salesy as this talk is going to get. And I promise it's not that salesy. But when you've worked with hundreds of customers on security issues, using Checkov, and, I get to work on the Checkov open source. I'm a Checkov and open source advocate at heart. You are going to, at some point, with a big enough deployment, a big enough code base, come to two questions. Next slide. The first one is prioritization. Because Checkov was designed for CI. You can throw it in your CI. You can have your developers run it in VS Code, so that those two tie together nicely in terms of what am I expecting and, then enforcing in the CI pipeline. And that's great. However, for most people running a tool like this for the first time, next slide, please. What we're going to see is something like this, right? Especially if you've enabled the CVE scanning as well. Let's say on a reasonably large code base, you're probably going to get, 1,000 issues from Checkov with your Terraform. Maybe another few hundred for Docker files it finds, and then maybe a few hundred CVEs in, your existing images that we detect. What are you going to do with all that realistically? Like, how are you going to prioritize that? And when we go back to kind of this idea of DevSecOps and security and dev and ops working together, this is always a sticking point, right? Because if you just turn something like Checkov in CI on in enforcing mode, a developer is going to go from a passing build to 1,000 things that they're being told they need to fix before that build that was passing yesterday can now pass again. And, it's not going to work. You're basically just going to alienate your development teams. It's never going to get more secure anyway, because developers are just going to start working around the CI. There's better ways to do it than that. So what can we do to prioritize this big list? Next slide, please. And what we can do is think like an attacker. We can think about, things being a graph, interconnected. A piece of Terraform doesn't just sit there on its own. It's part of what builds the infrastructure, which deploys your application, which configures a load balancer and things like that. So ask yourself this: if we have like an AWS load balancer and it's open to the world on all ports, which is bad, but if there's no backend service tied to that load balancer, it's not really an issue. There's a misconfigured piece of infrastructure, but it's not actually exposing you to anything because there's no application exposed behind it. So it doesn't really matter that security group is open to the world. Compared to this example, for example, next slide. If we have a load balancer open to the world, which is accidentally exposing a monitoring container or endpoint, which should be not world readable. And because of that, it's an old monitoring endpoint. It doesn't get that much love from security. It's running an old Docker image, which has a CVE. That being exposed to the internet now gives an attacker a CVE to access, get a foothold, and potentially then kind of move laterally into the Kubernetes infrastructure below it because of potentially other misconfigurations in the infrastructure as code. So that does have an attack path. So yes, you'd want to prioritize that over the first example. And the build versus buy, you could happily try and build something with Checkov to kind of highlight these priorities. But this is where I would say, ask yourself, what is it you're trying to achieve? What is the budget and the expectation in terms of your security posture? And I can't answer that for you. It's a per company, per team model. But we're doing a lot of work around this idea of visualizing like the blast radius and the attack chain. Next slide, please, with Prisma Cloud. Next slide, please, which is kind of built on top of Checkov to give you a lot more insight by adding all of these components together. Next slide, please. So as you can see, we can build this graph of this deploys this, which has these, Terraform vulnerabilities, but it's deploying this Docker container, which also has these CVEs. And you can see all of that in a single flow to help you prioritize, which of the hundreds of issues you need to tackle first. Hope that's been useful. I know I'm a couple of minutes over. Apologies for the interruption. And I do hope that apart from the shakiness making everyone feel seasick, you enjoyed your lunch. Thank you very much for having me.
Hi, we're from Effico, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at effico.com and enjoy the inspiring talks at the DevOps conference.